Don't blow it off. Don't sleep through it. Don't think, oh, I'll get it later, because chances are you won't. All right, so here we go. I went ahead and stapled my yellow sheet right to my notes. You certainly don't have to do that, but I do want you to make sure that you are learning the stuff on the yellow sheet, because it isn't a study guide that you get to use during the test. This is stuff you need to have memorized. Not immediately, but over the course of the next week or so. Okay, so trigonometry, triangle measurement. Okay, well, when you miss class, sweetie, it's up to you to do it. I'll get it for you later. All right, angle. An angle, everybody knows what an angle is, right? Anybody remember the definition from geometry? The union of two rays with a common endpoint. The union of two rays with a common endpoint. That's the definition of an angle. Two rays with a common endpoint. What do we call the common endpoint? Vertex. Yep, that's called the vertex. And then angles are measured by their rotation. So if, for example, this angle is going this way, if we're measuring it this way, this is called the initial side, and this is called the terminal side. So we start and end. And in a minute, we're going to talk about positive and negative rotation. But first, we have to make sure that when I draw an angle, you draw an angle, somebody else draws an angle, we all draw them the same way. So unless otherwise specified, angles in trigonometry are drawn in what we call standard position. And standard position means the vertex is at the origin, and the initial side is the positive x-axis. So when I ask you to draw a 30-degree angle, you're going to set up your coordinate plane, you're going to put the vertex right there at the origin, and you're going to start measuring on the positive x-axis. If you go counterclockwise, that's a positive angle. If you go clockwise, remember you're starting in the same spot because we're always starting on the positive x-axis. If we go counterclockwise, that's a negative angle. So we're going to draw all of our angles in standard position. There will be a few exceptions that we'll get to eventually, but basically, you're going to draw all your angles in standard position. If you go counterclockwise, it's positive. Clockwise, it's negative. Okay. Now, up to this point, probably, all of the angles you've ever measured have been in degrees. That's the unit that you have measured your angles in, right? I mean, like 30 degrees and 90 degrees. Just like there are other ways to measure weight and length. I mean, think about it. When I go to the doctor and get weighed, they don't even give me a pound measurement. I'm done in kilograms or something, right? There's different ways to measure weight, height, distance. Same thing with angles. Degrees are like the elementary measurement for angles. When you get further in math, and we're kind of in the transition year, after this year, when you take calculus, all of your angles will be measured in what we call radians. So we're going to practice going back and forth between degrees and radians. Now, what is a radian? Well, you maybe have a bit of an idea just looking at the word. It's tied closely to a circle and the radius of the circle. So a radian is radius form if we take a circle, and let's make the radius of that circle 4. If I took a piece of string of radius length, so 4 units long, if I took a piece of string 4 units long and wrapped it around the circle like this, so this is my piece of string that's 4 units long, the same as the radius, that is 1 radian. That angle is 1 radian. So how do you make a radian? You create an arc that is the same length as the radius. And that's how you get a radian. So if I had a circle, and this time the radius is 6, if I wanted to get a radian, then I would have to strike an arc 6 units long, and that would give me 1 radian. Well, this concept leads to a really, really important little formula. It's so simple, but it's important. What if I had a circle, and let's say the radius is 5. What if I struck an arc that was 10 units long? How big would that angle be if the arc was 10 units long? 2 radians, right? Every radius makes a radian. So the little formula that grows out of that is arc length arc length equals radius times radians. Now, if you look in your book, they're not going to say it that way. If you look in your book, they're going to say S equals alpha R. S is the letter they use for arc length. That's an S. Alpha is a Greek letter. Trigonometry was really studied by the Greeks, and so we use a lot of alpha, beta, gamma, theta, a lot of Greek letters. That's an angle. Okay, that's the angle. And R is the radius. I like to remember it. Arc length equals radius times radians, because then I remember that whatever angle I'm using has to be in radian measure. Okay? If you're going to use this formula, the angle must be in radian measure. So look, you knew that was 2 because 5 times 2 is 10. That's how that works, that little formula. You came up with it all by yourselves. Easy. Okay. Now, one more thing, and then we'll get into the meat of the notes there. Angles, degree measure angles. Radians, if we want to split them up, we just do it decimally. So we'll say 2.1 radians, or 1.8365 radians. Degrees can be split up into smaller pieces, and you may remember talking about this in geometry. You know how an hour on the clock, remember a good old-fashioned clock, like the round thing with the hands that go around? That is 360 degrees, right? The whole thing. But in an hour, it's 60 minutes. So an hour is divided up into 60 minutes. So is a degree. So 1 degree equals 60 minutes. And 1 minute equals 60 seconds. So you can have an angle of 30 degrees, okay? That's the whole angle of 30 degrees. Or if it's a little bit more than that, you might have 30 degrees and 5 minutes. That's the symbol for minutes. And if it's a little bit more than that, you might have 13 seconds. That's the symbol for seconds. So this is 30 degrees, 5 minutes, 13 seconds. That's an angle measured. Instead of doing it decimally, it's done in these little increments. Like if you were going to measure the room, you could say it is 13 feet, 6 inches. This is the same idea. When you're taking pieces of degrees, you use minutes and seconds. Now, in the old days, we had to do all that calculating by hand, but not anymore. Get your calculator out. Notice that the angle that you've been given is 136 degrees, 10 minutes, and 14 seconds, right? I'm in my notes, number 1. And we're going to change that. DMS stands for degrees, minutes, seconds. We're going to change that to a decimal. So instead of having it broken down like this, we're going to have 30 point something, a decimal. Okay, it's very simple. First thing I want you to do, and you need to kind of get used to doing this, is go to mode and make sure that in the, for me it's the third line down, but I'm not sure, the radian and degree one, make sure degrees is highlighted. So you want to put down and highlight degrees, just press enter, and then second quit. So now your calculator is in degree mode, which means every angle you enter is going to be interpreted as a degree. When we want it to be a radian, we'll have to go back in and change it to radians, okay? Now, here's what I want you to do. Pay close attention. It's easy, but you've probably never done it before. Press 136, that's our first number, okay? Now, if you go to second apps, it's actually angle. See how angle is written above your apps button? So press second angle, and the very first thing there is a degree mark. Would you agree? Press enter, because that's what you want. You want 136 degrees. Now, type 10, that's your next number, and go back to second angle, or second apps, and look what's right under the degree mark. The minute mark? So get that, press enter. So now you have 136 degrees and 10 minutes actually on your calculator. Okay, now here is the wacky part. In that list where we got the degree and the minute mark, they didn't put the second mark in there. I don't know why, but it's not there. So this is what you need to do. Type 14. And then alpha, the alpha button, plus sign. Notice that right above the plus sign, you see the two little hash marks? On my calculator, they're green. And when I have green things, it means I need the alpha button to get them. So you're going to get your degree and your minute mark out of your angle menu. Second angle, second apps. The second mark has to come from alpha plus. Okay, then press enter. And did you get 136.1706? And that is called the decimal degree. That is the degree measure as a decimal. All right, so let's do the next one. So 93/16/29. So here we go. Do you need me to say it, or you think you got it? Got it? Okay, let's type it in and see what we get. Is that what you got? Okay, so when somebody wants you to get a decimal degree from degrees, minutes, seconds, that's the process. Now, notice that question 2 is exactly the opposite. Go from the decimal degree to the degrees, minutes, seconds. Well, this is even easier. Type 103.74. Go into your angle menu, so second apps, and what do you see in that column? DMS. Highlight it, enter, and it comes up with 103 degrees, 44 minutes, and 24 seconds. Isn't that easy? I'm telling you kids, in the old days that took a long time. So the next one, 18.77. So we just hit 18.77. Second angle DMS, 18 degrees, 46 minutes, and 12 seconds. Is that okay? All right, now comes kind of the heart of the lesson. We need to be able to change back and forth between degrees and radians. Okay? We'll be using both. We're not going to quit degrees cold turkey, but the farther we go, the more time we'll spend in radians. But we'll still spend time in degrees. All right, so we want to know how many radians is 70 degrees. There's a very important relationship I need to share with you, and then I think you'll find these problems super simple to do. Yep. We're going to do this exactly, so we're not even going to be using our calculator. So not yet, we don't need to change it. So pi radians equals 180 degrees. So that's our basic conversion. You know how in chemistry you had conversions from centimeters to inches and stuff like that? This is your basic conversion. 180 degrees is pi radians. So that means a half a circle, a semicircle, is pi radians, okay? So we want to know how many radians is 70 degrees. So pi over 180 is 1. These are equal. Pi radians, 180 degrees. These are equal. I want to know how many radians would be equal to 70 degrees. If pi radians is 180 degrees, how many radians is 70 degrees? Does that proportion make sense to you? And then you'll just cross multiply and solve. So 180x equals 70 pi, and x equals 70 pi over 180, which reduces to 7 pi over 18. So that is the radian measure of 70 degrees. Try 120. Do exactly the same thing. You want to know how many degrees, or excuse me, how many radians is 120 degrees. So we know pi is 180, always. That will never change. Pi radians is 180 degrees. How many radians is 120 degrees? Did you get 2 pi over 3 when you reduced it? Now, back to Tyler's question. I'm not doing this on my calculator. This is called the exact answer. if I were to do this on my calculator, I would get a decimal for that would be rounded off, right? Just because, you know, pi is 3.14159 forever and ever and ever. You'd have to round that off. So anytime it says exact, it means we're not using our calculator to change back and forth. Okay, now for number 4, it says I can use my calculator, but I'm going to do exactly what I just did. Question 4a says pi is to 180 as x is to 7312. That's what I'm trying to figure out. What is the radian measure for 7312? Do I know how to do that on my calculator now? I think I do, right? X is going to equal 7312 pi over 180. I multiply this over there. So now I have to put in the 7312, and I know how to do that. 73 degrees, 12 minutes, times pi, and use your pi button, and divided by 180. Did you get 1.2776? Now the unit on that is radians. You do not need to write the word radians though, because in math, if you have an angle measure with no unit, we know it's radians. So if you were walking down the hall and found an angle whose measure was 3, you would know that means 3 radians. You don't have to mark it. You can if you want, but you don't have to. Degrees needs to be marked. So when you are labeling an angle in degrees, you need to use a degree mark. All right, let's do B. 190 degrees, 18 minutes, 51 seconds. We're changing it to radians. We're allowed to use our calculators, thank goodness, because it's a big angle. So pi over 180 equals x over 190, 18, 51. So you're solving for x. So 190, 18, 51 pi divided by 180. Remember where we get the seconds mark? That's the tricky one. .3216 if I typed it in right. Try to start making some connections, guys. Remember, pi is 180 and pi is 3.14. So this angle was 190. Doesn't it make sense that it would be just a little bit bigger than pi? Because 190 is just a little bit bigger than 180. Okay. Everybody okay so far? Now we're going the other way. 9 pi over 10. That's a radian measure, and we're changing it into degrees. You can set up the same proportion if you want to. But you're going to be doing so many of these. Let's think about a quicker way of doing it. We know that pi is 180, right? What would pi over 10 be then? If pi is 180, then pi over 10 would be, wouldn't that be 18? So pi is 180. So pi over 10 would be 18. And then 9 pi over 10 would just be 9/18. Okay, I can tell by blank looks that's not making sense. So we're going to go ahead and do it with our proportion.
What does it make sense to cross multiply 9 over 10 equals x over 180?
You have to be careful. It's pi over 180 equals 9 pi over 10 over x. That would be your proportion. So I don't remember everything you said, but if that's what you said, yes, that's right. So we have pi x equals 180 times 9 pi over 10. So basically my arithmetic is 10 into 180, 18 times 9, and then the pi's are going to cancel. So I don't know, what's 9 times 18? 162. So when I do this arithmetic, 180 times 9 divided by 10, or divided by 10 times 9, when I do that arithmetic, I get 162. So x equals 162 degrees. So you can always use your proportion. I don't for these simple ones. I just take 180 divided by 10 times 9. And that will give me 162. But you can always do it this way, if that makes more sense to you. So however you do it, do 7 pi over 9. How many degrees is 7 pi over 9? Basically, you're saying that's 7/9 of pi. Right? Pi is 180. So I need 7/9 of 180. So it's 140. You need to come up with 140 degrees. However you do it, as long as you're getting 140, you're doing it right. A whole pi is 180. A ninth of that is 20, and 7/9 then would be 140 degrees. Now, it's not that easy for the next one, because the next one just says 3. There's no pi in it. So we got to change 3 radians into degrees. So I'm going to fall back on my proportion. This works all the time. Why is the x in the denominator? Earlier today I had it in the numerator. Why do I have it in the denominator now?
Because you're finding the radian.
Exactly. This is pi radians in 180 degrees. So whatever I put over here has to be radians over degrees. Okay, so pi x equals 540, and x equals 540 over pi. And that's my exact answer. It's not pretty, but that's the exact answer. 1.6 radians. Pi is to 180, as 1.6 is to 1. That's the question. Pi radians is 180 degrees, so 1.6 radians is how many degrees? You can use your calculator for the arithmetic. So I got 288 over pi. Pretty easy, right? All right, let's look at the next one. 6a. A 100-degree arc of a circle has a length of 7 centimeters. So let's draw a picture of it. So we have a circle, and we have a central angle of 100 degrees. And the length of the arc is 7 centimeters. So this right here, this is the arc length. That's 7 centimeters. And we want to know what is the radius of the circle. Now there are a couple of ways that we can do this. If you remember earlier, I had you write down that arc length equals radius times radians. And I know my arc length is 7. I have no idea what my radius is. And I don't have the radian measure of the angle, but I do have an angle. Could I change 100 degrees into radians and then use that number in my little formula? Okay, so let's do that. So this is not going to be the answer to the problem. This is going to be like a little intermediate step. Over to the side. Pi is 180. What is 100? That's the question. How many radians is 100 degrees? So 100 pi over 180. Did you get 5 pi over 9?
Yep.
Now that is not the answer. 5 pi over 9 is the radian measure of this angle. So instead of being 100, I'll think of it as 5 pi over 9. And now I can plug it in for the radians here, 5 pi over 9. And now I'll solve for r. How will I solve for r? I want to know r equals. How will I get r by itself? What can I do? Multiply by 9? So that would be 63 equals r times 5 pi. And then divide by 5 pi. And the unit on that is centimeters, because the arc length and the radius will always have the same unit. So if the arc length is centimeters, my radius will be centimeters. Okay, now, Grace, I know you need to go. I want you to hang on for just 1 second, because I want to do this problem another way. I want you to have options. One option is always to remember arc length equals radius times radians. The inconvenience of that is sometimes your angle's not in radians. So you have to change it first, which is not a big deal. You just have to do it. The other way to do the problem is the way you probably did it in geometry. What is the circumference of this whole circle? What's the formula for the circumference of a circle? Do you remember? 2 pi r. And since I don't know my r, that's the best I can do. I know that this piece of the circle, though, is a piece of the whole circumference. So I could set up a proportion that said 100 degrees is to the whole circle as 7 is to the whole circumference. In geometry, we call that part to whole or piece to whole, and we set that proportion up a lot. So the 100 degrees is to the whole circle, as the 7 is to the whole circumference. Now, if we cross multiply, we have 200 pi r equals 360 times 7, which is 2520. So r equals 2520 divided by 200 pi. Now, with any luck, what did I get for my radius? I erased it. Anybody write it down? I erased it. What did I get for my radius when I did it before?
63 over 5 pi.
53? 63 over 5 pi. Okay. So now what I'm going to do is I'm going to reduce this fraction, and with any luck, these will come out to be 63 over 5. So 2520 divided by 200, math frac, oh my gosh, 63 over 5 pi. So I've done the problem both ways now. You don't have to do it both ways, and you don't have to know both ways. Yeah, no one way. All right. What is the perimeter of a 10-degree sector cut from a circular disc with a radius of 11? What in the world does that mean? Here's my circular disc, and it has a radius of 11 inches. And I'm going to cut out a 10 degrees is very small. I'll make it a little bigger so I can write inside of it. But there's a 10-degree chunk of this circle. The word sector means piece of the pie. So this is referred to as a sector, a piece of the pie. So here's my 10-degree piece of pie, cut out from this thing with a radius of 11 inches. And I want to know what the perimeter, I want to know what the perimeter of this sector is. So this is the perimeter, the purple. That's 11, isn't it? Wouldn't that be another 11 right there? So what I really need to figure out is, what's my arc length? Now, I just gave you two options to find arc length when you're getting degrees. Okay? So see if you can, one way or the other, find this arc length. I'll call it S, because that's what your book does. Let's see if you can find S. Either by doing radius times radians, or by setting up a proportion like, proportion like this one right here. See if you can figure it out. And I'll do it too, but I won't say anything. We'll see if we can come up with the same answer. I'll do it both ways. So you can check yours no matter how you did it. I did it both ways. So if you did not get 11 pi over 18, let's talk about it. For the arc length, not for the final answer, but for the arc length. Let's talk about who did not get 11 pi over 18. Okay, which way did you do it, Brenda? Did you do it with finding the radian measure first?
Yeah.
Okay. So that's what this work is right here. I'm finding the radian measure. So pi over 180 equals x over 10. So I multiplied the 10 over here, so 10 pi over 180, and then took out the zeros, so that's 1 pi over 18. Now that is the radian measure of the angle. So my arc length is radius times radians. So I had to take 11 times pi over 18, so I got 11 pi over 18. All right? Anybody else? We need to be able to do this kind of problem. Anybody else have a question about that? Didn't get 11 pi over 18.
Why did you multiply the 11 with the 2?
Did you do it this way?
Yeah.
Okay, so I set up my proportion. The angle is 10 3/60ths, and then the arc length is from the whole circumference. What's the formula for the circumference of a circle? 2 pi r. So it's 22 pi is my whole circumference. Now I'm solving for s. So I multiplied this over here, got 220 pi over 360. And then I just reduce the fraction. 220 over 360 is 2236, which is 11/18. Now, we did it both ways. We got 11 pi over 18, that's the arc length. So the perimeter would be 11 plus 11 plus 11 pi over 18. So 22 plus 11 pi over 18 inches is the perimeter of that sector. Remember, the question asked for the perimeter. So we have to add up all of the sides of that sector. Okay? Remember, we got to stave off the boredom, people. Boredom leads to bad test scores. Force yourselves. Force yourselves, force yourselves. Here we go. The concentric circles of an archery target are 6 inches apart. The inner circle has a perimeter of 37.7 inches. What is the perimeter of the next circle? Okay, so what we're talking about is a target like this. These are called concentric circles. They have the same center. Now it tells me that they are 6 inches apart. So this distance right here is 6 inches. Would you agree with that? Now the inner circle has a perimeter or a circumference. Sometimes when I take problems out of IB books, they use a little slightly different vocabulary, but the perimeter of the circle is the circumference, right? So I know that the circumference of this circle is 37.7. And I want to know the circumference of the purple one. Okay, who's got an idea? I think this is doable. Tyler?
37.72 pi r.
Okay, so he says, first of all, let's find the radius of the inside circle. So 2 pi r equals 37.7. So r equals 37.7 over 2 pi. Now they used a decimal, so we'll go ahead and use a decimal. Let's take 30, be careful. If you're gonna type this in on your calculator, remember, you gotta have that in parentheses or you won't get the right answer. Whenever you divide by more than one thing, so 37.7 divided by parentheses 2 pi, and I got 6. Did you get 6? So my radius is 6. Now what? That wasn't the question. I want to know the purple thing. What's the circumference of the purple thing? What can I do now? The radius of the purple then wouldn't the radius of the purple have to be 12? So we're just basically finding the circumference when the radius is 12. So decimally speaking, what is that? $75.398. Is that right? Gosh, that wasn't as hard as I thought. Okay, a lot of trigonometry is used in navigation, so we're going to get started talking about some navigation stuff. Find the angle in degrees that describes the compass bearing northeast. Okay, so let's make sure you're all familiar with a compass. And let's talk about navigational angles here. So here's my compass. Here's due north, right? South, east, west. Navigation is an exception to the standard position rule because in navigation, so when we talk about ships sailing or airplanes flying or whatever, due north is 0. Due east is 90, south is 180, and west is 270. So when someone's flying on a course of 100 degrees, they're flying down here like this. Okay? So we got to know these are the headings when you're talking about navigation. Find the angle in degrees that describes northeast. Now, northeast would be directly in the middle of north and east, right? And if it's directly in the middle, what would be the measure of this angle? This one's 90. What's this one? 45? Northeast is 45. It's right in the middle of north and east. Now, what about northeast? Well, can you see how northeast splits the northeast quadrant? You have this half and you have this half. This half is referred to as the north side of northeast, and this is referred to as the east side of northeast. So right in the middle here is northeast, and right in the middle here is east-northeast. Does that kind of make sense to you? So, same thing down here. Let's do this one. This would be southeast. This one would be the south side of southeast. And this one would be the east side of southeast. So anyway, they want the angle for north-northeast. What would this angle right here be? North-northeast. What angle would that be?
67.5.
North-northeast is 22.5. In standard position, it would be 67.5, but in navigation, it's measured from due north. So you're going 22.5 degrees from due north. This one would be 67.5. And west, southwest. All right, west, southwest. Now, here's southwest. And then west, southwest would be on the west side of that. Right? Now, what angle is that? 247.5 is our guess. What do the rest of you think? I think he's right. Because right in the middle here would be 225. And we figured out that these little radial increments are 22.5 degrees, so he's going another 22.5. Is that right? Yeah. Perfect. Perfect, perfect. Okay. Now you're going to sketch your own courses. So just remember, this is the setup. 0 is straight up, and you go clockwise when you're doing navigation. We're not going to do that in regular trigonometry, but in navigation, that's the way it works. So did you do a 35, something like this? Nobody's got a protractor, nobody's measuring it. Do you have it something like that? That's good. 128? Something like this? And 310. Degrees, but all the way around past 270. So you're up here, 310. The captain of some boat follows a 38-degree course for 2 miles and then changes to a 47-degree course for the next 4 miles. Draw a sketch of this trip. Where this is going is, soon, we'll have that exact situation. We'll say the ship sinks, you're back at port, send a rescue plane, tell them what course and how far to go. Right now, all we're doing is drawing a picture of where the ship is. That's the first step. So, what's it look like? Here's my compass. Start right there. 38-degree course. Something like that. And it's for 2 miles. So I'm going to go ahead and label that 2. Now, I don't know how fast he's going. Doesn't matter at this point. They tell me he goes 2 miles. Now he's going to change course. So I would suggest that you put, here's where he is now. I'm going to put another little compass point here. And now the second leg of the journey is going to be 47 degrees. And that's twice as long because he went 4 miles that time. So now this is where the ship is. And that's all you have to do, draw a picture of it. There it is. Now, like I said, eventually, you're going to have to figure out this distance, and you're going to have to figure out this angle. And that's all trigonometry. You'll know how to do that. That'll be easy for us. All right, G. Oh, wait a minute. Okay, G. Let's see if we can get this problem done. 2 Coast Guard patrol boats leave. Okay, so the picture's drawn for us. One travels. Okay, everything's drawn for us. If they travel the same speed, approximately how far apart will they be when they are 25 miles from Cape May? So you've got one ship here and one ship here. And they're both 25 miles away. And we want to know this right here. Would you agree with me? How far apart are they? Okay, how are we going to do that?
Hey, Drew. How are you?
Well, do I know this angle by chance? of that angle the difference between 5212 and 4230? How am I going to subtract that? Oh, I could change it to a decimal? Absolutely. That's not what I had in mind, but that'll work, right? So I was typing in 52 degrees, 12 minutes, minus 42 degrees, 30 minutes. I hope this works. 9.7? And that's degrees. Okay, good. Now what? So I can either change that into radians and find my arc length, or I can set it up as that proportion and say 9.7 over 360 equals x over 2 pi times 25. All right, well, I want to practice with radians, so I'm going to do that. So I'm going to change 9.7 into radians. So I will say pi over 180 equals x over 9.7, and that's not this x. I'll change this to an s. So 9.7 pi over 180 is my radian measure of this angle. So my arc length is my radian measure times my radius. So I'll type that in on my calculator. And I got about 4.23, is it miles or kilometers? Miles. Can anybody confirm that for me? Is that about right?
Good afternoon, Cathedral.
Just another
As we
application
come to the end of this day, let us
formula.
pause for prayer. And two of the best cures for the winter